Right, now let's discuss the second problem, which is the storage capacity or the active storage capacity requirements of a reservoir dam. Right? So again, this problem or example is just taken from example 7.20 in Chin 2013. And this is, you're basically given a 24-month data, all right? And what they did here, in order to actually zoom in into the most critical or the worst case scenario that the dam may experience in its lifetime, is they actually looked for a 24-month drought record, all right? And this will be the basis of our active storage capacity, all right? A 24-month drought. And the data contains your average monthly inflow or water inflow from the watershed, and then the average water demand. All right, so this is probably a projected demand from the population that will be served by the dam. And they also factored in other things that can increase the consumption of water, like irrigation and evapotranspiration. All right, so this demand here, this number or these numbers, is a number that factors in the demand, the irrigation, and even the evaporation, right? So this table is just a 24 month data showing the inflow and then the demand per month, and the data is given in cubic meters per second. All right. Again, just to refresh you regarding the mass curve analysis or the ripple analysis that we use in order to determine the biggest deficit, water deficit that the dam will experience, what we do in the mass curve analysis is we just have to take the cumulative volumes of the inflow and the demand, and then subtract the values and the biggest in order to get the cumulative deficit. All right, so what happened here is, all right, so I'll just show a step-by-step solution here again. So let's go back again to the Excel solution. My first column here is the months, like starting from January until December for the next year. Month number from 1 to 24. And then another column is the average inflow rate in cubic meters per second for 24 months. And then the next column is the average demand in cubic meters per second. Now note that when we are comparing months, or when we are talking about comparison of months, always remember that months don't have a constant value of days. All right. So we have to factor that in. So what happened here in the next columns is we converted the cubic meters per second into cubic meters per month, right? So you have to multiply the second by minutes, by hour, by, and then finally by the number of days you have in a month, right? Now you can easily manipulate this in the spreadsheet, and you now have your monthly volumes, right? So you might wonder why we don't just subtract the the monthly volume from the why don't we just subtract the monthly demand from the monthly inflow, all right? So so if we just subtract the monthly demand from the monthly volume without taking into account the cumulative numbers, we are essentially just getting the deficit for that month, all right? So for example, if you get a deficit in the first month, all right, and then you get another deficit for the second month, note that the dam has to catch up with the deficit from the first month, and then in the second month, it also has to catch up with the deficit from the first and second months. All right, so the deficits are is something that that is something that just accumulates. All right, so that's why we calculate deficits in terms of cumulative deficit. All right. It's like having debts or utang. I mean, it just piles up every month or every year if you don't pay. Right. So anyway, to get the cumulative inflow and cumulative demand, all you have to do is just sum the values. So what I did here is I just used the sum formula, and the first entry is just the first data point to the first data point. So that's my range. F3 to F3. But for the first number, I added a dollar sign on F and 3 to indicate that this value will be fixed. All right. So if you propagate this formula, all right, F3, the first value will be anchored on F3. All right. And you just do the same for the cumulative demand. You just anchor the first value to the first data set. And finally, all we have to do is we just subtract the cumulative demand from the cumulative inflow, right? And all we have to do is just look for the biggest deficit that will occur in this period. So you can just look for the value manually, or you can just use the minimum function. All right, so the smallest value here is, or the biggest deficit we have here is in the month of August, in month number 20. Although there are other big deficits here, like in the month of August, in month number 8, and also September. All right. So the beauty of having cumulative deficits is that it accounts for all the deficits that or for all the sums of deficits that can occur within this period. So if you're designing for the active storage capacity for dam, you only have to design for this event or for this deficit, all right, which is 4 billion cubic meters, right? So that concludes the tutorial for the storage capacity of dams. The next video will be about the design of well fields